everybody, welcome you all. Today I will discuss about the pair of straight lines. Let me begin from the very first part of the pair of straight line. Okay, so as per the book, I have a little scanned copy of this book. So over here I have scanned a little part, not the entire portion, the selected portion from this pair of straight line. So over here, what we are doing is that we shall ultimately consider general equation of second degree, as I discussed in the chapter of pair of general equation of second degree. Hmm. But what we shall discuss over here, we shall discuss this kind of equation that ax square plus twice hxy plus by square plus twice g x plus twice hy plus c is equal to 0. I told you in last class that this kind of expression represents a pair of straight line provided the determinant delta. The determinant delta becomes is equal to 0. This determinant delta becomes is equal to 0. That was a result. And depending upon different cases, that d may be greater than is equal to 0 or is equal to 0 or not equal to 0, depending upon different situations, we sometimes get parallel straight lines, we sometimes get intersecting straight lines. So d is equal to over here a b minus h square. Okay, now I shall come to this general result, but today at first, actually the entire chapter is divided into two portions. In the first part, today we shall discuss the first part of the chapter. In the first part, we consider only this much, that is actually the purely second degree term. This is x square, so x into x is there. This is x into y, so degree is 2, and this is y square. So we shall consider this kind of expression is equal to 0, and that is called homogeneous expression. Why homogeneous? Because it is actually, we can say that all the terms are of second degree, but the actual definition of homogeneous function that would be discussed later. There is a chapter called functions of several variables in your differential calculus or real analysis. Probably I can't exactly tell you about the paper. You might have seen the syllabus. By the way, did you get the syllabus? Hello? Did you get the syllabus?
So which one? That completed one?
Yes, sir.
Yeah, the complete syllabus.
Yeah, we got it.
Okay. So if you go through that portion, you would find one chapter that is actually called the functions of several variables, or function of more than one variable. There you would get the exact definition of definition of homogeneous function. Hmm. And this kind of expression would ultimately be a homogeneous function. For the time being, at least you can say that this the entire all the terms in this entire expression are of second degree, and that's why this is a homogeneous equation of second degree involving two variables x and y. But you will get the general definition in the chapter of functions of several variables. So I'm not going to discuss all this over here. Over here, simply we say that this is a homogeneous second degree, purely homogeneous second degree equation, and that is the general second degree equation. Okay, general because of the fact that it involves the first degree term as well as the constant term. And this is particularly called the homogeneous second degree equation involving two variables x and y. We are first going to prove that this kind of expression always represent a pair of straight line passing through the origin. Whatever be the value of a, b and h, we are going to first show that this kind of equation always represents a pair of straight line passing through the origin. So let me draw a picture for you. We are going to show that, say, these are the two axes, and suppose this is one straight line and this is the second straight line. And over here we are going to show that this kind of expression always represents these two kind of straight line passing through the origin. Okay, how to show this result? We are dividing this expression by x square. Over here you see, in order to become this expression as a second degree expression, over here a and h and b, they cannot together become equal to 0 simultaneously. Okay, so at least one of these three quantities a, h and b should be not equal to 0. Anyway, so we divide this expression by x square. Then we get this kind of equation, and this can be written in this way: b into y by x whole square plus twice h into y by x, twice h into y by x plus a is equal to 0. Now we suppose that y by x is equal to m. In that case, this equation would give us b into m square plus twice h into m plus a is equal to 0. Now if we want to solve the values of m, you would possibly get two values of m. This is the total solution: minus twice h plus minus 4h square minus 4ab. This is the 4h square means square of twice h. So twice h whole square, that is actually 4h square minus 4ab. So we can take this 4 common, and if this 4 is taken outside the this square root symbol, in that case it would be 2, and these 2 would get cancelled with these 2 and these 2. Altogether we can cancel all these 2, and ultimately we would have this type of results. Suppose for one symbol, maybe for positive value we call it m1, and for negative value we call the value as m2. Okay, and this there is a standard result regarding the roots of a second degree equation. You already studied second degree equation in Bangla যেটাকে বলে দ্বিঘাত সমীকরণ. So you already studied this kind of second degree equation, and there was a relation. There we had a relation in between the roots and the coefficients. Okay, so from that result we can say these two, sum of these two roots m1 and m2. So we can say that m1 plus m2 is equal to, with a negative sign, with this negative sign, coefficient of m divided by coefficient of m square. So we shall have twice h divided by b with this negative sign, and the product of these two roots m1 and m2, this product must be is equal to the constant term divided by the coefficient of m square, that is equal to a by b. Okay, so over here we have these two results, and try to remember these results by your heart. নিজের নামের চেয়েও ভালোভাবে জানো এই জিনিস, এই রেজাল্ট দুটো মনে থাকে। আমাদের খুব কাজে লাগবে। These are very useful results. So over here we actually get two values of m. Let us call them m1 and m2. Now if suppose for m is equal to, if we put m is equal to m1 in this relation, in that case we will get y by x is equal to m1. For m is equal to m2, we would get y by x is equal to m2, and therefore y becomes is equal to m1x, and second equation would be y is equal to m2x. So y is equal to m1x and y is equal to m2x. These are actually two straight lines. Okay, y is equal to some constant into x. This kind of expression always represent a straight line, and over here we get two different values of m, and therefore we can say that these two relations, or these two equations together represent two straight lines. One straight line must have the gradient m1 and another straight line must have the gradient m2. বাংলা যেটাকে বলে প্রবণতা, gradient means প্রবণতা. Okay, so let us say the first straight line has the gradient, say m1. Suppose this straight line has the gradient m1 and this straight line has the gradient m2. M1 or maybe greater than m2 or m2 may be greater than m1, we don't know, but whatever be the result, at least we can say that y is equal to m1x and y is equal to m2x. These two relations are obtained from this kind of, from the by the decomposition of this kind of expression, isn't it? So we can say that this kind of expression always can always be decomposed into this kind of relations. Two and these two relations together represent two straight lines. That's why we say that this kind of relation represent a pair of straight line, and these two pair of straight lines are passing through the origin. মূল বিন্দু বা 0 0 পয়েন্টের মধ্যে দিয়ে এই স্ট্রেট লাইন দুটো পাস করবে। ওকে, ইজ ইট ক্লিয়ার টু ইউ?
Yes, sir.
Now one question arises. If suppose m1 becomes is equal to m2, or suppose m1 and m2 are complex conjugate numbers, then what happens? Okay, if by chance m1 becomes is equal to m2, in that case these two straight line would coincide with each other. One straight line would be exactly identically same as the second straight line. That's why I am saying that one straight line will coincide with the second straight line. Got it? And there, in that case, these two equations would be repeated, but these two equations would be same kind of equation. Suppose m1 and m2 both have value is equal to 3. In that case, y is equal to 3x would appear for the first time, and for the second time again y is equal to 3x would appear. Therefore, we can say that these two straight lines, if m1 becomes is equal to m2, these two straight lines would be coincident straight lines. And what would be the condition under which these two values m1 and m2 would be equal? The condition is that h square minus ab, this expression under root, this expression h square minus ab would be equal to 0. Okay, and if h square minus ab becomes is equal to 0, then you see this d becomes is equal to 0. Therefore we can say that if by chance d becomes is equal to 0, then these two straight lines would coincide with each other. একটা আরেকটার সাথে just মিলে যাবে, coincide করে যাবে। Okay, so this is the condition under which given this kind of purely second degree homogeneous equation would represent a coincident straight line. The condition is that ab minus h square must be is equal to 0. Okay, and if this h square minus ab is strictly greater than 0, in that case the values of m1 and m2 would be real and distinct. Real and distinct মানে আলাদা আলাদা দুটো ভ্যালু পাওয়া যাবে, m1 and m2 would have two different values, and in that case these two straight lines would be distinct or different straight lines, but both of these two straight lines must pass through the origin. That is the main point I would like to highlight over here. All the straight lines are passing through the origin. Okay, and by chance, if h square minus ab, if this expression h square minus ab becomes less than 0, by chance if this h square minus ab becomes a negative quantity, in that case m1 and m2 would be some complex conjugate numbers. M1 and M2 would be some complex numbers, and in that case, when M1 and M2 are complex numbers, in that case we do not actually have any real geometric interpretation of a straight line in a two-dimensional plane. So we cannot say that y is equal to m1x and y is equal to m2x. For complex values of m1 and m2, we cannot say that y is equal to m1x and y is equal to m2x represent two straight lines in this kind of two-dimensional xy plane. But the progress in mathematics is not very fast. The problem is that I am just trying to share a story with you that whenever the complex number was developed, it was mainly developed from the question that what would be a number x such that x into x, that means x square becomes is equal to a negative number, particularly x square is equal to -1. Okay, so if x square is equal to -1, such kind of no such kind of real number exists, and just from the sense of negligence, mathematicians called them imaginary numbers. Got it? Just from the sake of negligence, these are very less significant kind of numbers, and they cannot arise in our real world, and that's why they called them imaginary numbers. And so a plus I into b, I is the imaginary number, I square is equal to -1, and mathematicians were doing different difficult kind of problems by the help of this kind of so-called imaginary or less important or less significant numbers. Okay, so it is actually the story of about 16th century, and after about 300 years, these imaginary numbers got their geometric interpretation after about 300 years. And by that time, although we had a little confusion in our mind regarding the geometric application or geometric significance of complex numbers, however, complex numbers were used in our different computations. That's why in this case also, when m1 and m2 becomes complex numbers or imaginary numbers, in this case also we cannot say, at least they represent two real straight lines in xy or in this kind of two-dimensional xy plane. But we keep the option open for any future study, because we don't know whether in future we will get any kind of geometric interpretation of this kind of equations when m1 and m2 become complex numbers. Okay, so that's why we keep this option open, and we say that y is equal to m1x and y is equal to m2x represent two complex straight lines or imaginary straight lines. Complex or imaginary means they are not real, so we cannot draw any real straight line for imaginary values of m1 and m2. However, we keep the option open for our future study when m1 and m2 are imaginary number or complex numbers, and we simply call them complex state lines. That's why if we summarize the total discussion, we can now say that this kind of equation always represent a pair of straight lines passing through the origin, and these straight lines may be real, distinct, or this may be real, coincident, or this may be imaginary lines. Got it? So that's why we have this result that a homogeneous equation of second degree always represent a pair of straight lines passing through the origin. Got it? It always represents a pair of straight line passing through the origin. Now, do you have any question? Is it clear to you? Do you have any question regarding this portion? সবার কাছে কি ব্যাপারটা ক্লিয়ার হলো? Hello?
Yes, sir. Yes, sir.
Now, we have one more result that we shall mostly use, that this kind of direction. You see, over here, if you consider this left hand side expression, now take this b common. In that case, you would find that this kind of expression ax square plus twice hxy plus by square can be written in this way: b into y minus m1x and y minus m2x. These are actually the results of your second degree equation. বাংলা যেটাকে বলে দ্বিঘাত সমীকরণে তোমরা এই টাইপের রেজাল্ট করেছো। So I think you all know all these type of results. Now, so this is the condition h square minus ab less than 0. This is the condition under which this kind of straight line becomes imaginary, and h square minus ab greater than is equal to 0 means straight lines should be real. For particularly for when h square minus ab becomes is equal to 0, the straight lines should coincide with each other. And remember, h square minus ab is exactly opposite to the expression of capital D. D is equal to AB minus H square, not H square minus AB. Okay, so in order to represent a distinct real straight line, so in this case D must be less than or is equal to 0. So this part is a bit confusing portion, so be very careful about it. Okay. now now we now need to discuss about the angle between these two pair of straight lines. What would be the angle between these two pair of straight lines? We know that if y is equal to m1x and y is equal to m2x are two individual straight lines represented by this kind of purely second degree homogeneous equations. In that case, we have this type of results: m1 plus m2 is equal to minus twice h by b, and m1 m2 is equal to a by b. These are known, so far known result, and in future we use these two results as two standard formula. Okay, so m1 plus m2 is equal to minus twice h by b, and m1 m2 is equal to a by b. These are two standard formula. Now you see, we know that tan theta, if theta is the angle in between these two straight lines, say this is the angle theta. Say this is the angle theta. If theta be the angle between these two straight lines, in that case, we know that tan theta can be represented in this form: m1 minus m2 divided by 1 plus m1 m2, or it can also be written in the way that m2 minus m1 divided by 1 plus m1 m2. Okay, and that's why we generally write this expression as m1 difference m2. So this m1 difference m2 means this is the operator, difference operator. Got it? This is the symbol tilde notation. This is the difference notation: m1 difference m2. So we say that M1 minus M1 difference M2 means it may be M1 minus M2 and it may be M2 minus M1. But what would be the exact situation, especially whenever we have three different straight lines? Sometimes we need to follow certain particular order. I shall discuss all this in our subsequent discussions. Okay, in our subsequent lectures. So for the time being, at least, let's continue with this M1 difference M2. So over here, M1 minus M2 is there, or M2 minus M1 is there. You see over here. Suppose let's write it over here. Okay, after this time. Suppose M1 difference M2. Hmm. And this can be written as, it may be M1 minus M2, it may be M2 minus M1 whole square, and then it's positive square root. As because we are free to choose M1 minus M2 or M2 minus M1 as the case may be, so it is always possible to make this expression positive. Hmm. We are not considering the negative square root, because M1 minus M2 and M2 minus M1 can be manipulated in such a way that ultimately the expression becomes positive. Okay, so we can consider it as a positive square root. And now this expression, forget about the positive sign, this expression can be written as, if this is M1 minus M2 or M2 minus M1, whatever it is, we can write it as M1 plus M2 whole square minus 4 into M1 M2. Okay, and that is the operation we have over here. This M1 minus M2 can be represented as the positive square root of M1 plus M2 whole square minus 4 into M1 minus M2 divided by 1 plus M1 M2 is there. No problem is there. Actually, our target is to express the entire expression either in terms of M1 plus M2 or in terms of M1 M2, M1 multiplied by M2, so that we can use these two results. We can use this M1 plus M2 is equal to twice H minus twice H by B, and M1 M2 is equal to A by B. So our target is to compute this expression. Over here you see we are not interested in the individual values of M1 and M2 so far, at least. We are trying to compute our required quantity. Over here our target is to compute tan theta. So our target is to compute tan theta over here. That's why we are trying to compute the main objective or the target expression without exactly computing the individual values of M1 and M2. And this approach is most of the times applied in case of mathematics, because sometimes in mathematics computation of M1 and M2 might be difficult if the corresponding relations in between M1 and M2 are very complicated. Over here, at least, the relations are not so much complicated. The relations are easy, but we always try to apply this technique, that we always try to avoid the difficulty arising in our computation, and our target is to find the particular quantity on which we are interested. Okay, so this kind of approach are actually called qualitative approach. We don't exactly quantify the quantity. That means we don't know the expression of M1 and M2. So we are not interested in the quantity or the value of M1 and M2. Actually, our target is to find the expression of tan theta or the expression of this quantity by the help of these two results. That's why we made such manipulation that ultimately everything is converted into M1 plus M2 and M1 multiplied by M2, so that now we are able to apply these two results and we over here apply these two results, m1 plus m2. So m1 plus m2 is equal to minus twice h by b, and m1 m2 is equal to a by b. Got it? So over here again we are applying m1 m2 is equal to a by b, and afterwards it's a matter of little manipulation, and if you manipulate all them you will observe that the total result ultimately becomes is equal to 2 into root over of h square minus ab divided by a plus b. So try to remember this result by heart at least. Tan theta is equal to 2 root over of h square minus ab divided by a plus b. That is again a standard formula that we shall use in future without any deduction. Okay, tan theta is equal to 2 root over of h square minus ab divided by a minus b. Again you see we have the expression of root over of h square minus ab, and I told you that this m1 and m2 would be two real straight lines whenever h square minus ab is greater than is equal to 0. So if this quantity is greater than is equal to 0, if this h square minus ab becomes greater than or is equal to 0, in that case tan theta would be a real number. Otherwise, if h square minus ab is less than 0, in that case tan theta would be an imaginary number. And if theta is imaginary, it means that no such real line exists. That's why theta is imaginary. Got it? So that is the definition of that is the formula of tan theta. Hmm. And one more result is that sometimes we from this result we try to compute the condition under which these two straight lines m1 and m2 coincide, and if m1 and m2 becomes coincident to each other, in that case theta would be is equal to 0. So if theta becomes is equal to 0, in that case this tan theta would also be is equal to 0, and tan theta is would be 0 only when h square minus ab is equal to 0. So we already have the result. We previously proved this result. That is again one more verification of the previous result. That's all. Hmm. And one more result that is relevant with this discussion is that sometimes these two straight lines become perpendicular to each other. একটা আরেকটার সাথে 90 degree অ্যাঙ্গেল তৈরি করে থাকে one straight line makes an angle of 90 degree with the other straight line. Okay, so what would be the condition? You see over here, if theta becomes is equal to 90 degree or pi by 2, in that case tan theta would be plus infinity or minus infinity. I don't know. Yeah, actually tan theta is undefined. Yeah. Tan theta is theta, as theta tends to plus or minus pi by 2. Tan theta is actually undefined. Anyway, so that is this quantity would be an undefined quantity. Sometimes somebody call it infinity. So this is an undefined. This would be an undefined quantity only when this a plus b, this quantity a plus b becomes is equal to 0. Got it? So this is the condition under which these two straight lines a plus b, these two straight lines form right angle, or they are orthogonal to each other, or they are perpendicular to each other. Okay, so this is the condition a plus b is equal to 0, under which these two straight lines become perpendicular to each other. Now is it clear to you everybody? সবার কাছে ব্যাপারটা clear?
Yes, sir.
Okay, so now I am starting the last part for today's discussion. I am interested to compute the bisector of the angle in between m1 and m2. Okay, so over here the angle in between m1 and m2 means this is one angle, and this expression, this is another angle, isn't it? That would be pi minus theta. So if we say that what is the angle between m1 and m2. In that case, tan theta would give us this angle, and correspondingly we would always have another angle, pi minus theta. So now our target is to compute the bisector in between these two straight lines. Bisector মানে বাংলায় যেটাকে বাংলায় যে কি বলে সমদ্বিখণ্ড, হুম সমদ্বিখণ্ড বা bisector, that means a straight line which would equally divide the angle theta and the angle pi minus theta. So two straight lines are required. Let me try to draw these two straight lines. One is this kind of straight line, and another would be this kind of straight line. So these are the two possible straight lines that would divide these two angles. One is the angle theta, another is the angle pi minus theta. Okay. Now I am going to discuss the problem by choosing a point, this kind of point. There are two different approaches present in this book. I am considering the second approach. Let us consider a point. I don't know what point is this, maybe P. Okay, let's write it as P, or maybe something else. Anyway, let's see what is, yes, they have taken this point as the point P. So my picture is exactly very similar to this picture. Okay, and now I am considering this alternative approach. From this straight line P, we are trying to draw two perpendicular lines. This is suppose one perpendicular line, and this is suppose another perpendicular line on the straight lines y is equal to m1x and y is equal to m2x. And let us suppose that P has the coordinates x, comma y. Got it? So this is the point P, and P has the coordinates x comma y. And what would be the perpendicular distance? You see the equation of the straight lines are y is equal to m1x and y is equal to m2x. These are the straight lines. And from this point P having coordinates x comma y, what would be the perpendicular distance without modulus symbol? A modulus symbol should be used over here. Forget about the modulus symbol. So without the modulus symbol, the perpendicular distances would be y minus m1x and divided by root over of 1 plus m1 square. Another would be y minus m2x divided by root over of 1 plus m2 square. So actually, as because the distance is non-zero, we should use modulus symbol over here, isn't it? So forget about this plus or minus symbol. If we apply the modulus symbol, no plus or minus symbol would ultimately come. But that plus or minus symbol would ultimately come if we remove this modulus symbol, because some positive or negative quantities ultimately would arise. Now, is it okay with you, this relation y minus m1x divided by 1 plus m1 square? Hopefully you know all this formula of distance. এই ব্যাপারটা জানো তো?
Yes, sir.
So these two distances must be same, because over here P is a point lying on the bisector. Therefore this much distance and this much perpendicular distance, these two perpendicular distances must be same. Okay, and now our target again is to apply these two results only. M1 plus M2 is equal to minus twice H by B, and M1 M2 is equal to A by B. We are not interested to compute the individual values of M1 and M2. However, with the help of these two results, our target is to express or convert this relation into a suitable relation. Let's see what happens. You see, firstly we take the square root, so that this positive and negative sign, this confusion would not appear at all. So we are making the square on both sides, and then we cross multiply both of these two sides. So after making square, what we shall have? Y minus m1x whole square. This is y minus m1x whole square multiplied by 1 plus m2 square. So this is the expression multiplied by 1 plus m2 square. Okay. Similarly, over here, the second part is y minus m2x whole square, the another cross multiplication divided by 1 plus m1 square. Clear? So that is the result. And now if you expand this expression y minus m1x, then we will have this type of result: m1 square x square plus y square minus twice m1 xy. And over here, if we expand y minus m2x whole square, you will have the result m2 square x square plus y square minus 2 m2 into xy. So we have these two results. Now we have a little bit of manipulation over here. I am trying to demonstrate the manipulation. Okay, and please remember whether we have any. Yeah, I already have the ready-made manipulation. So let me delete this one. Hmm. So over here we have this type of result. And you please try to work out all this type of calculations by hand in your home, because this would make yourself you to generate some confidence in you, so that you would ultimately be able to compute all this kind of results in the exam. Because this type of deductions are many similar deductions would be selected in exams. Okay. Anyway, so what we are doing over here, you see, we are choosing the coefficients of x square. Over here, how to generate x square? If you multiply this m1 square with 1 plus m2 square. So this is the one expression. And from this right hand side, if this m2 square is multiplied by 1 plus m1 square, this would generate this second term. So that's why I'm using x square with this negative sign over here. So this would be the coefficient of x square. Fine. Similarly, we can compute the coefficient of y square. How to compute y square? This is 1 plus m2 square. And from the right hand side, what would be the coefficient of y square? 1 plus m1 square. So this would be 1 plus m1 square. Again, we compute the coefficient of twice xy. So with this negative sign, minus 2 m1 into 1 plus m2 square. So 2 is taken over here, and minus m1 into 1 plus m1 m2 square is there. And similarly, this minus sign would ultimately become plus on the left hand side. So twice m2. So 2 is taken over here, and therefore we have m2 into 1 plus m1 square. So m2 into 1 plus m1 square would appear over here, and the right hand side becomes equal to 0. Now what happens over here? M1 square into m2 square would get cancelled with this negative m2 square into m1 square. Okay, so ultimately we shall have m1 square multiplied by 1, that is m1 square minus m2 square multiplied by 1. So ultimately we should have x square, the coefficient of x square would be m1 square minus m2 square. Similarly, over here, this 1 will get cancelled with this 1. So ultimately, we would have the coefficient of y square is equal to m2 square minus m1 square. And over here, if we manipulate the coefficient of xy, you see, we shall have from this part m2 minus m1. So we have m2 minus m1. Again, from the remaining terms, we can take m1 m2 common. So we shall have m1 minus m2, and that is equal to 0 over here. So now what we are doing over here, you observe that this is m1 square minus m2 square, and this is m2 square minus m1 square. So in order to take something common out of these two terms, we can choose m1 minus m2 square common. In that case, some negative sign would ultimately come over here. So we shall have x square minus y square within bracket, and this entire expression is taken on the right hand side. Okay, therefore this m2 square minus m1 square would be m1 square minus m2 square, and this positive sign becomes is equal to negative sign. We are keeping m1 minus m2 in a similar fashion, so that in the next term we can again take this m1 minus m2 common, and within bracket we shall have 1 minus m1 m2. And you see, uh, in order to get a bisector, this m1 must be different from m2. If m1 becomes is equal to m2, in that case these two straight lines, this m1 and m2, if both of these two become equal, this is a very important part. You see, this if this m1 and m2 becomes equal, in that case these two straight lines would coincide with each other, and theta would be is equal to 0, and therefore no existence of this bisector would ultimately possible. Okay, so if m1 becomes is equal to m2, I am repeating this one. If m1 becomes is equal to m2, in that case, no such angle would be possible. No such positive angle would be possible. Theta would be is equal to 0. And if theta becomes is equal to 0, then the question of bisector would never come. So if we want to find out the bisector, it is obvious that m1 and m2 must be different. That means m1 should not be is equal to m2. Okay. So if m1 is not equal to m2, if m1 is not equal to m2, we can cancel this m1 minus m2 from both sides. And then after cancellation, we shall have this type of expression. And afterwards we are just putting the values of m1 plus m2, that is actually minus twice h by b, and m1 m2 is equal to a by b. And therefore if we take the LCM over here, it would be b minus a divided by b, and this divided by b, this b in the denominator, this b in the denominator would cancel with this b, so ultimately we shall have this type of result. And so we have ultimately the equation would be y square minus x square divided by b minus a, that is actually xy divided by h, and this can be written as x square minus y square divided by a minus b is equal to xy divided by h. Okay, so this is the equations of bisectors. Both of these two bisectors over here, we are just for the sake of simplicity, we are taking p on this straight line. So it does not mean that p should always lie on this kind of straight line. You see, the position of p might also be on the this second bisector. Got it? And in case of second bisector as well, we shall have this type of two distances, and these two distances must be equal, and again we shall have the same type of exactly same type of expression or equations. Therefore this kind of straight line and this kind of straight line, both of these two straight lines would be represented by this second order equation. You see, we have x square related term, we have y square related term, and we have xy related term. So this is actually a homogeneous equation of second degree, and it always represents two straight lines passing through the origin. So what are these two straight lines? These are the two straight lines, this bisector and the second bisector. These are the two possible straight lines. Okay, so this is the equation of bisector of the given straight lines. Is it clear to you, everybody?
Yes, sir. Clear.
Clear?
Yes, sir. Yes, sir.
Okay. Now the last part, as a corollary to this discussion, I would like to mention that suppose if this A becomes is equal to B, it may so happen for certain equations A might be is equal to B. It is possible. It's quite possible. You see, and in that case, this division would not be permissible. Okay, So in that case, what to do? In that case, we should just multiply this expression by the right hand side. Then this expression can be written in this way, that x square minus y square is equal to a minus b divided by h, and if a becomes is equal to b, so in that case we can say that this expression becomes is equal to 0. The right hand side becomes is equal to 0, and therefore in that case x square minus y square would be is equal to 0, or x is equal to plus minus y would ultimately appear. তোমরা x is equal to plus minus y হিসেবে bisector equation দুটো পাবে. Similarly, if suppose h becomes is equal to 0, then what you need to do, you just multiply this h by this left hand side. So you will get xy is equal to 0. That means x is equal to 0 and y is equal to 0 would be the bisectors. Got it? So that is the one point I wanted to mention. And secondly, over here you see, um, in if you express this equation in this way, in that case you see the coefficient of x square, let us call it capital A, and the coefficient of y square is equal to would be minus 1. So over here a is equal to plus 1 and b is equal to minus 1. Therefore we obtain that a plus b is equal to 0. That means coefficient of x square plus coefficient of y square becomes is equal to 0. Coefficient of x square and coefficient of y square, the total sum becomes is equal to 0 for this kind of equation. We know that this equation represents a pair of bisectors. Okay, so we can say that these two bisectors would always be perpendicular to each other. This is the condition of perpendicularity. Under this condition, a pair of straight line becomes perpendicular to each other. So this equation, as because this equation represents the pair of straight lines, that is actually the bisectors. Therefore, we can say that these two bisectors would always be perpendicular to each other. Got it? Is it clear, everybody?
Yes, sir.
Now that's all I wanted to discuss. Thank you for having patience.